This is a limiting reagent problem, and we can tell that because we're only dealing with reactants here for C6H12 in the O2. Remember, the aim of this is to figure out which one of these gets used up first, and that will be the limiting reagent. As in the past, I'll use the cheese sandwich analogy to describe what's going on here. So let's say you had 2 bread and 1 cheese, and that would give you 1 sandwich. And if we started out with 4 bread and 5 cheese, you could see that the most we could end up with here is 2 sandwiches. As you can see, the bread would be the limiting reagent. Bread gets used up first, and we would end up having 3 slices of cheese left over. And the reason we know it's 2 sandwiches is we take the 4 bread and we divide it by 2. That tells us we're going to get 2 sandwiches at the end. Alright, so we're going to do something similar over here. We're going to figure out the number of moles of C6H12 we're dealing with. Then we're going to divide by the number of moles in the reaction equation. We're going to do the same thing with the O2, figure out the number of moles of O2, divide by the number of moles in the reaction equation, and that's going to give us 2 mole ratios. Whichever one has the smaller mole ratio is the one that ends up being used up first. It's something similar to what we use over here. We can see that 4 slices of bread would give 2 sandwiches, 5 slices of cheese would give 5 sandwiches, so this one, the bread would end up being the limiting reagent. Alright, so starting out, we've got 54.0 liters of C6H12. Times and a line, we know that liters of C6H12 goes on the bottom. We know that moles of C6H12 goes on top because that's what we're looking for. The liters here have to cancel, that's why I put liters on the bottom. The relationship between these, 1 mole is equal to 22.414 liters of C6H12 times, and then a line, we're going to divide by the number of moles in the reaction equation, which is 1, and remember, times 1 over something is the same as saying divided by, so 1 mole C6H12 over here, and that's going to come out at 2.41 would be the mole ratio there. Remember, there's no units on this. The moles cancel, the liters cancel, so we're just left with that. Now down here we'll start off with the oxygen. We've got 7.00 liters of O2 times, and then a line. We'll have liters of O2 on the bottom. We'll have moles of O2 on top. That's what we're looking for. The relationship between these, 1 mole of O2 is equal to 22.414 liters of O2 times, and then a line, 1 over the number of moles of O2 in the reaction equation, which is 9 moles of O2. So that gives us 0.0347 as our mole ratio. As you can see, this one has a smaller mole ratio, so the limiting reagent is going to be O2.